I am Shijie and I'll be going through my math assignment on Euler formula. So first, on the left side of this page, you can see that the graph with a curve of the differentiation equation. And suppose that we already know the value of xn, yn, and we need to find the next point, xn plus 1, yn plus 1. So Euler method assumes that over a small step size, the tangent line at the current point is a good approximation of the curve, which allows us to estimate next value using the slope of the tangent. So the slope of tangent line is given by the same as the differential equation formula, m equals to yn plus 1 minus yn over xn plus 1 minus xn. And we define h equals to xn plus 1 minus xn, which after substitution will give us dy dx equals to yn plus 1 over minus yn over h. And then we rearranging it to get yn plus 1 minus yn equals to h times dy dx. And since dy dx equals to f times f bracket xn yn, we will get yn plus 1 equals to yn plus h times f bracket xn yn, which is the formula of Euler. So the differential equation is dy dx equals to x squared plus 2 over y, where the initial condition was y0 equals to y bracket 0 equals to 1, and the step size is h equals to 0.1. So column D shows the solution of the derivative of the formula x squared plus 2 over y, which is the gradient. And column E is where the formula is put in place, where my yn plus 1 equals to yn plus h times f bracket xn yn. Okay, so for the initial value, we will use the initial value to find step 1. So step 0 will be x equals to 0 and y equals to 1. So using the formula, we'll get that 0, we'll get 1 plus the derivative, we'll get 0.1 times the derivative value of 2, which will end up with 1.2. And we will do the same for the rest of the steps, using the previous steps value to get the answer for my y. And general formula and some errors that the Euler method might have. So the general solution is, as y's, you'll get y dy equals to x squared plus 2 dx, and then integrating both sides to get half y squared equals to 1/3 x cubed plus 2x plus c, and then subbing the y bracket 0 equals to 1, we should find c to be half, and then after subbing x equals to 1, we will be able to find the value of y of 2.38. So some mistakes that the Euler method might have is that we are using approximate values of each step. So they will accumulate at each step, which will become a bigger error since we're using truncated values and not the exact value of each step, which will cause accuracy issues. And I hope you have a great day ahead.